Okay, in this video we're going to continue looking at dealing with a series of even cash flows. So those are annuities again, and now we're going to look at present value of annuities. So now we're asking how much a series of cash flows that we're going to receive over future periods is worth today. The formula for the present value of an annuity is equal to the payment times, in parentheses, 1 over r minus 1 over r times 1 plus r to the nth power. Again, we're not going to derive that, or actually I suggest you don't even use the formula. Much better to use Excel to figure out the present value of annuities. We're just going to be solving for the present value. And we'll have the 4 other inputs, the FV, the N, the I, and the PMT. If we have those 4 inputs, then we can solve for the present value. So as an example, let's consider this. I receive $25,000 at the end of every year from the Idaho Lottery Commission. If the appropriate interest rate is 8%, how much is that annuity worth if it's going to last for 20 more years? So using the formula, I would put in the payment, $25,000, and then start filling in the bits inside of the parentheses. So 1 over r would be 1 over 0.08. And from that I'm going to subtract 1 over r times 1 plus r to the nth power. So I stick in all the 8% and the 20 powers, and I end up with, at the end of the day, a present value of all those future cash flows equal to $245,000. Now notice, if I just added up all the checks over 20 years, that would be a total of $500,000 in receipts. But in today's dollars, in today's money, with a discount rate of 8%, that's really only worth to me the amount of $245,453. And let's take a little aside and look at doing calculations with periods other than years. So to this point, I think we've done everything with years as the periods, but that is not necessarily how cash flows in the real world work. There are a number of different timelines, a number of different schedules that cash flows happen. So for instance, monthly house payments, bonds typically pay semi-annual coupon payments, so we have cash flows that are occurring every 6 months. There are quarterly dividend payments, so every 3 months a company might pay a dividend, or you might be receiving a dividend payment. Many people have money taken out of their paychecks every 2 weeks or twice a month on payday, and that's going into their 401k account. So we have a variety of different periods other than just once per year. So if the money is earning interest all that time, we need to account for the compounding that's going on and the interest that's being earned before the year end happens. Okay, so we need to adjust our calculations and adjust the way we're thinking about the calculations to take into account that interest is being earned along the way. So the way we do that is to adjust those periods, and we're going to just do that by following this little algorithm here, where the number of periods, the N per, that input is going to be equal to the number of years, but we're going to multiply that times the periods per year. So how many periods are in a year? If we had semi-annual payments, the years would be however many years these semi-annual payments are going to happen. And then the periods per year is going to be 2, so we'd multiply the number of years times 2, and that would tell us the number of periods, the number of 6-month periods that are going to be in our calculation. If we're talking about months, obviously we're going to take the number of years, multiply it times 12 to get the number of periods. If it's a payment that happens every 2 weeks, we're going to take the number of years, and there are 26 2-week periods in a year, so we would multiply the number of years times 26, etc. So that's going to be our N per entry in Excel. That's the number we're going to use for that argument in all of our functions. And again, it's the number of periods, not the number of years. We need to adjust another thing. Besides just the number of periods, we also need to adjust the rate to reflect a periodic rate. The rate is not going to be an annual number unless the period is a year long. So the way we adjust the interest rate is to take the annual rate and divide that by the number of periods per year. So for instance, if we have 6% interest over the course of the year, but we're sticking in money every 6 months, then we're going to have a periodic rate of 3% every 6 months. Sometimes banks will compound interest on a quarterly basis, maybe on a monthly basis, even sometimes a daily basis. So we might take to get the periodic rate, we would take the annual interest rate and divide that by 365, and that would give us the periodic interest rate. So as another example here, if we were talking about semi-annual investments in an interest rate of 7.5% for 6 years, the number of periods would be 12 because that's equal to 6 years times 2 periods per year. And our periodic interest rate would be 3.75%. And that's just equal to the 7.5% annual rate divided in half because we have 2 periods per year. Let's go to Excel and take a look at some calculations using periods other than years and look at a few examples here. The first one, what is the future value of my investments if I contribute $300 per month to my 401k for the next 30 years and I earn 9.9% per year? So the problem tells us that our periods are month long, so we're going to have 12 periods per year. And as we start to fill in these pieces, our present value is going to be 0. We're starting with nothing. We've got 30 years, but we're going to multiply that times 12 periods per year, and so we have a total of 360 periods. Our periodic interest rate is going to be equal to the 9.9% annual number, but we're going to divide that by 12, again, because we have 12 periods per year. And then finally, the payment. The investment is going to be a negative $300. We're contributing $300 every month. And so we stick that in as a negative 300. We go up here to the future value. We're going to solve for the future value. And we use the future value function equals FV. And then I go to each of those cells and input the appropriate amount. So the interest rate is going to be in cell B7 here. That's the periodic rate. Cell B6 is the number of periods. Now we've adjusted it to take into account that this is a monthly set of cash flows. B8 is the payment, the regularly recurring payment of negative 300. B4 is the present value, which is 0. And we get our number, get our answer. And the answer is $663,850 after the 30 years. All right, let's look at another example here. What is my monthly car payment? So again, we're dealing with months, so we'll have 12 periods per year. What's the monthly car payment if I borrow $29,000 for a new car at 3.49% annual rate over a 5-year loan? So we've got the present value, that's how much we're borrowing. Notice that I made that a positive sign because we're getting the benefit of the $29,000. The future value is 0. We're going to pay off that loan, and there's going to be no extra cash flows happening at the very end of this 5-year loan. The number of periods is 5 years times 12 periods per year, so that gives us 60 periods. The periodic interest rate is going to be equal to the annual interest rate of 3.49% divided into 12 parts because we've got 12 months, so the periodic rate is basically 0.291%. And if we solve for the payment using the payment function with all the appropriate inputs, the rate, the number of periods, the starting value, and the ending value, and again, I don't need to put in the type because we're assuming end of month payments here, then my answer, the payments are going to be $527.43 every month for the next 60 months to pay off my car loan. And then finally, what annual interest rate is my bank charging me if I'm borrowing $200,000 for a mortgage and my monthly payments over a 30-year loan are $954.83 per month? So now we're solving for the rate, and we're going to fill in all the inputs that we have from the problem. Our present value, we're starting off with $200,000. I'll go ahead and format that a little bit better. We're starting off with a present value of $200,000. It's a positive number because we're getting that from the bank. The future value is 0 because we're going to be paying off this loan over time. At the end of 360 months, there's going to be no extra cash flows to pay. The number of periods is 30 years times 12 periods per year, so we've got 360 of those. The payments are given to us as $954. I'm going to put a negative sign in front of that because it is a payment. And then I use the rate function, solve for the rate with the number of periods, the payment, the present value, and the future value. And when I hit enter, I get 0. And hopefully by now you realize that the first thing I need to do is add some more decimal places. So we're going to add at least a couple of decimal places. And now my result says 0.33%. But we need to keep in mind that this is a periodic interest rate. So that's a monthly interest rate. And at least in America, we don't talk about interest rates in terms of monthly numbers. We don't talk about monthly interest rates typically. We generally will discuss interest rates in the context of being an annual number. So what I need to do to finish this off is annualize this answer. So I'm going to multiply my output, the 0.33%, times 12, and this is a more appropriate answer. 4% is the interest rate that the bank is charging me. That's an annual number, and it's understood to be an annual number, and so that would be the correct answer and the final answer. If you stop here, you've given a partial answer. You haven't kind of completed everything. The other thing what you could do is within the formula itself, multiply that times 12 to reflect that this is we need to adjust the output to make it an annual number. And if I did that, then I would get the right answer in this cell here. Obviously, this would not be correct anymore. So be careful with the number of periods and the periodic rate. That's a kind of a common stumbling block. So make sure you're adjusting them in an appropriate fashion. Let's wrap up the series of even payments in the next video. We'll pick up with perpetuities and look at what a perpetuity is and look at some examples and talk about that in Excel. So I'll see you in the next video.